Well, hello again. You already know me, so I'm not going to present myself again. So this is Marcos 2.0 after two caipirinhas. Let's see how it goes. So I have only five or 7 minutes, so this is going to be fast. So please pay attention. So building and shipping Go applications with Docker. So I'm pretty sure that mostly all of you know Docker, so that's nice. And a lot of you also do Go, so I'm pretty sure that you're already shipping static binaries into production, and that is really cool because it's small containers, and that's nice. And I'm going to show you some tips and techniques that you might or might not use in your development environments and companies, which are quite nice, and it already helped me to do stuff. So the first thing is that if you don't have Docker Go installed, and you only have Docker, you can already build stuff with Docker without having Go installed locally, so you can just basically pull a Go image, and you can just do go get any repo, any binary, and you can just extend the application, right? And you can do it in a disposable container, so you don't have any trash in your environment. Another thing which is super nice to do is that you can actually switch Golang versions by just specifying the Docker image version, right? Docker image tag. So you can use like the 1.5, 1.6, or 7 tag. And you can easily build applications for that specific Golang version. So if you want to try new stuff, or if you don't want to change your own environment Golang version, you can just super easily do it this way. Another cool stuff that you can do is that if you actually put the /bin, the /home/bin path in your path local environment, you can actually go get stuff by mounting that path with a container, and what you would do is you're gonna download the Golang repo, you're gonna build it, and you're gonna leave it in your path, right? Because you mounted it. That way, you can actually get stuff, build it, and it will be already available in your Go path in order to run it. But one thing that you need to take care of while doing this is that if you have a Mac and you do this, the installing your system step, then you're going to be installing the Linux version of that binary, basically, because as you already know, Docker runs on Linux, basically. So, well, it runs on Windows now, natively, which is quite nice. But if you do it in a Mac, you will have to specify like the cross-compilation stuff, right? So you can do the goes and gorge variables, and you leave it in your bin, and you are set to go, which is nice. So this is the building part. What about shipping? Well, I'm pretty sure that you all do static binaries, which is nice. And you have two ways of doing static binaries. I'm pretty sure that most of you do the Cgo enable 0 local environment, which is nice. But if you do that, then you won't be able to use the the user/OS package, because that package also uses C, right? Uses libc underneath, which will be using glibc in most of the cases if you're using like Debian or Ubuntu, and you won't be get rid of glibc. So one thing that I do, which is pretty nice, is I use Muscle. Does anyone know Muscle? Muscle is like a libc implementation, but it's written like correctly, you know, because glibc is full of crap. You can statically compile it, but it's quite difficult. But if you use Muscle, it's super nice. So I actually use Go build, and I tell Go build to use an external linker, which is Muscle, right? And with the link mode external, so that will use Muscle to externally compile my program instead of the Go built-in linker. And I pass the external linker flags, so I tell Muscle, okay, my binary is going to be static, and I also do the X main version thing. That X main dot version, it will allow you to override a variable inside the Go program, right? So each time you compile your static binary, you can set an internal variable that you can print it later to see which version your binary has, basically, which is nice. And later on, once you have your static binary, it's just a matter of using Scratch image and copy your binary into the container, and you're going to be good to go. I'm pretty sure that for all of you that already use static binaries, which are not based on Muscle, if you're using HTTPS, you need to copy the SSL certificates, because otherwise it won't work. And I've described how to use Docker to build stuff locally, and how to ship it into production as static binaries. But what about doing a workflow that does all this, right? Because I described it in 2 different steps. So if you want to do a workflow about this, you have two ways of doing it. This way is one way that, I don't know if you heard of Jerome Petazzoni, which works for Docker. So J Petazzo is his handle. He recommends to do it this way, right? You have a Docker compose file. Well, you have two Docker compose files, sorry. The first one, which will be a build compose file, and the second one, which is going to be a production compose file. And the first Docker file is going to actually build the binary, the static binary. So you use the image, you just mount your path, so it takes all the libraries that it requires. And then it's going to leave that binary in your environment, in your local environment. And then you use a second compose file, which is the one that is actually going to build the image. But I don't like this approach very much because it lacks a couple of things. The first thing, it relies on your local path to build in your local Go path to build the image, which is not very nice because you might have like a lot of stuff in there and you need to mount it into the container and that's it, to bind mount it. And you need to run two separate commands and you need to rely on the local storage because you need to build the binary locally and then you need to mount it on the second step with the previous Docker file that I showed before. So the way that I do it, which I found it's a bit of a trick, but it's nice how it works. So I have two different Docker files, right? I have like a build Docker file and a run Docker file, which are these two. And one thing that is quite nice is that Docker build can actually get the context from standard input. I don't know if you know that. I mean, if you send a tarball into Docker build, that tarball will be the actually context where Docker build runs. So the first Docker file only builds my application. I mean, it's copying. The first step that it does is copying this Docker file into its context. Then it just copy my local code into the path of the container. Then it's setting the work here so I can build the application. It's doing go get, so it goes and gets all the dependencies of my application. It builds the application with the flags that I showed before. It's setting then it changes the work here again where the binary is. And then what I do, where the binary and where the first Docker file is. And then what I do is I run tar and I just output all the stuff that's on the /go/bin directory through standard output, right? Then I can pipe that standard output to another Docker build, which is this Docker file through standard input. And then it's going to, all this is going to work like a workflow. So I build in one image, I just spit it through standard output, and I pipe it through a different process through standard input. So if you want to run and build this application, you don't need to do this, right? So what I do is I do a Docker build. I build that Docker file into a builder container. Then I run that builder, which is that Docker file with outputs through standard input my tar content, which is my binary with my other Docker file. And then I do pipe Docker build -t with that's going to be the tag of my image. And then I'm going to specify that this Docker build is going to take to standard input what it needs to build, right? So with that, I have only one command, which is pipe, of course, between two Docker builds. And I have my image ready. So I don't need to have compose, I don't need to have anything but Docker and my application to get running. Thank you. That's all.
Really super happy.